How do you do, ladies and gentlemen, and boys and girls? I'm Julius Sumner Miller, again, still. And my principal business is physics. And today, a program which I entitle Some Extraordinary Adventures. Some Extraordinary Adventures. Consider the following, and some of the results you will hardly believe. I have here a flask with some water in it, and I have applied some heat from below, and the water is boiling. We say the water is boiling when the vapor pressure given off by the water, delivered by the water, is equal to the atmospheric pressure on it. Now I am going to remove that boiling flask to a cold tripod, and I'm going to shut off my gas burner, shut off the gas, and I have put this tightly stopped on this cold tripod, and you see an astonishing thing. Well, somebody says, what's astonishing? The water stopped boiling pretty nearly. Yep, the water stopped boiling pretty nearly. It'll stop altogether pretty soon. And I have it tightly stopped. Now what am I going to do? From time to time, I'm going to lay my hands, which are colder, of course, at a lower temperature than that flask. I'm going to lay my hands on there, and the water will boil. Now, because it's too hot for my hands, I'm wetting my hands a little bit in some ice water. Now, watch, 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 watch. Oh, yes. Notice the laying on of hands. I have boiled the water. Now, you must give me your undivided attention to another matter. You see, I am boiling water there by applying heat. But over here, I have another demonstration where I'm going to boil water not by applying heat, but by taking heat energy away, and I'm going to boil the water so fast that it's going to get so cold by evaporation that it freezes. Now, who'd believe that? So here's what I have. I'm going to take a little watch glass in which I put a little water, and I'm going to put a bell jar on top of that, on a pump plate which has a hole in it, and I'm going to take out some of the air from here with a vacuum pump. Pump, 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 pumping out. So the pressure in here gets less and less and less. Now, less and less pressure in here means that the water in here can evaporate more and more and more readily. Now, you know evaporation is a cooling process. So as the water evaporates, it is cooling down. Its temperature is getting less. But pretty soon, the vapor pressure of the water will be equal to the pressure in the bell jar, which is very low. And so at this time in our affairs, we say the water is boiling. But remember, I've applied no heat to it. It's boiling because I reduced the pressure and let it evaporate so that the vapor pressure is equal to the pressure in the bell jar. Now it is boiling. Now it is boiling without the application of heat. But it's boiling in such a manner that it is losing its heat energy because I'm not applying any. And what do you suppose will happen? It may, I hope, if things work, if I have tight enough vacuum, it will freeze. So I'm going to freeze the water in this little watch glass by boiling it. More than that, I should add a phrase. I have below, in the setup in my apparatus, a little vessel of concentrated sulfuric acid, because concentrated sulfuric acid is hydro something. It takes up water vapor. So the water vapor that comes off here goes in there. Now, do you notice how I attacked this matter? I said it's hydro something. So here is a good idea for looking up words and adding to your vocabulary. This contributes nothing to my experiment. So I'm going to go to this. But before that, has not the water here ceased boiling? Now watch me lay on my hands again. Watch me. And I say the laying on of hands is a mysterious thing. Watch it. Oh, there it goes. There it's boiling again. Now, if we can get the camera tightly on the little watch glass in my chamber here, very tightly, so that we see the water in the watch glass. There we are. Now I'm going to start the pump, and we will silently pray for the success of this. Watch it now. First, you see it clouded up a little because of an instantaneous reduction in pressure. Stay right on the water. Now I see some occluded gases which are locked up in the water, leaving the water. They are gathering there in little bubbles. Now the water is beginning to boil. And I'm tightening the bell jar. Now, let us hope. The water is boiling. Rapidly. And it takes a couple minutes or 3, depending upon how good a pump we have. The water is still boiling viciously. On occasion, some gases locked up get released, and flip, they go. Watch closely. This takes a little time. Now things are quiet. All the gases locked up in the water have fled away because of the reduction in pressure. Oh, there was a little there. The water now is very cold because it is evaporating at very low pressure. One needs to have patience for this experiment. There it is! I say we have ice! Oh, man alive! Let me shut this off. Let me take this out. I want to show you that I've got ice. There it is. Now, ladies and gentlemen, just look at that. That's ice. How do I show it? There it is. There's a piece of... Ah, that's pretty. That is ice. And I say, this is fantastic. And if anyone has any other view, he is lifeless and dead. This is absolutely enchanting. So what did I do? I froze water by boiling it at lower and lower pressure, at lower and lower temperature, which bears on the following. You go to the top of Pike's Peak. You can wash your hands in boiling water. Why? The atmospheric pressure is so low, the boiling temperature is very low. The vapor pressure of the water need be very low in order to equal the pressure of the atmosphere on it. You can't cook beets in an open pot less than 2 hours, if then. And as for brewing tea, the water hardly gets ever hot enough to take the juices out of the tea leaves. Now, let's get back here. But before, I suppose, ladies and gentlemen, I have done this experiment 10,000 times in 50 years. And I am repeatedly enchanted by this adventure. Look at that. Oh, the ice is gone. It's melted. But is this not a dramatic adventure? Let's go back. Do you see the water in this chamber is absolutely silent, lifeless, dead, and quiet? And I am going to lay on my hands. Watch it. A little cold water. Watch it. You say the right abracadabra, the right hocus pocus, in Hindustani or Swahili. Boil. Ah, there it's boiling. Ah, man alive, that's something. Now, how long can I continue to boil that water? Oh, about an hour. Well, let's go on. Some exciting adventures. I have another exciting adventure. Notice, people. Let's get back here to my experiment on the freezing of water by boiling. You remember I said I had a little sulfuric acid in this lower chamber, which is right there. Now, some of the water vapor some of the water vapor went into the sulfuric acid. And what is the interaction of water with an acid? Answer, exothermic, meaning that heat is evolved. So, if you give me your attention here closely, if I feel this chamber now of acid into which some water vapor has gone, I would feel it what? Answer, I would feel it hot. And so closeth the adventure magnificent to witness. Here is another one that's wonderful. I have here some ice cubes in a glass of water. Some ice cubes. I have here a string, and my problem is to get out. So I'm wetting that string a little bit in another dish, so it takes on a little rigidity and weight. I wish to get out some of the ice from that glass of water by a strange and uncommon device. Watch me. Watch me closely. I want to get out some of the ice from this vessel. How can I do it? Can't wrap the string around. I'm not allowed too many accessories, but I am allowed one, and here it is. Salt in a salt shaker. I'm going to put some salt on there, and I'm going to wait a moment, and now you know a strange thing happens. A very strange thing happens. What happens? The salt depresses the freezing point. Some of the ice is melted by the salt, whereupon water arises, so the string finds itself embedded in a little puddle of water on a hunk of ice. But because there's lots more ice than there is water right there, the water that resulted from the melting ice now freezes, and the string is fixed to it. We hope. Watch it. Watch it. Watch it. Watch it. Watch it carefully. There it is. I have lifted some ice out, and that is a wonderful adventure. Indeed, have I not called this program Some Remarkable and Extraordinary Adventures in the Subject of Heat? Incredible. Incredible. Oh, let me try it once more. The water is silent and quiet and still. Not any evidence of boiling. I'm going to lay on my hands again. Watch it. Watch it. Boil, my dear, and it boileth. Thus readeth the scriptural lesson regarding the boiling of water. And would you not agree, ladies and gentlemen, that these investigations have uncommon beauty and drama, enough to stir the deadest soul? And I thank you for watching.